Okay, back to where we were. So I was saying that you need to change it to this expression to standardize it. Then you can use the mean and variance as 0 and 1 respectively. But then the question for some students will be like, why do I need to change it? Why can't I just use 7 and 35? Right? Yeah, it's so mafan. It's so troublesome to change it. Okay? There's a reason why. There are only a few scenarios, or rather there's this one particular scenario where you have to use standardization. Okay? The most prominent question setup is that you do not know the mean or variance or both. Understand?
Yeah.
Yeah. Actually, this is not one. This is the only reason why you have to use it. You do not know the mean or variance or both. That's all.
Okay.
You only use it that way. Okay. To fill you in a bit more, we can go to an example. Let's take a look at this. Okay, maybe not this. Let's say this. Okay, let me. Okay. With me?
Yeah.
You there, right?
Yeah.
Okay, let's take a look at this question. Okay, just a bit more. By the way, I have to end at 7 because later I have another class. After this. Yeah. Okay. The heights in meters of a certain population of adult males follow a normal distribution with mean, mu, and variance sigma square. Okay, up to this point, what should we do?
Write down.
Write down what? What's step 1?
Define.
Define what?
The definition.
Yes. So what is the definition? Can you write down for me?
Be the height. I don't know. Let X be something.
Let X be what? Height of what?
Adult males.
Yeah, lor. Just copy and paste. Height in meters of a certain population of adult males. Remember, this in meters is very important. You don't have to write this. No, don't have to write this. You have to write this. It's fine. The height in meters of adult males. That's all.
Am I supposed to write the 10% thing?
Then what's next? Okay, no, up to this point only. So from here, you know that X follows normal distribution, mu, and sigma square, right? Okay, so now we go on to the next statement. If 10% of the population have heights greater than 1.8 meter and 5% have heights less than 1.6 meter, find the mu and sigma. Okay, so the second statement, so this is part 2, right? This define the distribution. So what is step 3? Define the
And the probability, the problem.
yes. Can you write it down for me?
But there's 2 though.
Yeah, just define both. No, don't do this first. Don't do this first.
Then
Define the problem first.
how do I define the problem?
Yeah, which is probability of x greater than 1.8 meters, right? Then carry on. Yeah, then. What's the probability of x greater than 1.8?
Is it?
Yes, carry on.
Is it just that?
Yes. So from here, right, they want you to find the mu and the sigma. How are you going to do that? Okay, the only way you can do that is that, you're going to have like, at the end, you're going to have mu equals to this, sigma equals to this, right? Correct?
Yep.
Yeah. But in order to do that, that's why I say the only way when you have to standardize is when you don't know the mu, you don't know the sigma, or you don't know both. So the next step will be to standardize, which is what you wrote earlier over here. So this is where you write your z. Let z be equals to x minus mu over sigma for lowest normal distribution 0, 1. Okay?
Okay.
Yes.
Yep.
Then after that, in step 5 is when you transform the equation. You understand what I'm trying to say? So you will change this to x minus mu over sigma greater than 1.8. Sorry, my bad. Greater than 1.8 minus mu over sigma equals to 0.1. So from here, you can confidently conclude that z is greater than 1.8 minus mu over sigma equals to 0.1. Okay? But then from here, how are you going to find the mu and the sigma? Okay? Because the mu and the sigma right now is in the limits, right? Right? It's in the limits. So how are we going to find the limit?
You use inverse.
Yes. Can you do that for me? Use what? Inverse norm.
But then the mu and the sigma, what do I put it as?
You cannot put anything. You are supposed to find that.
Oh, do I put as 0 and 1? No.
What do you mean? Your
Because if you
you mean
norm,
on your calculator? You mean on your calculator, right?
yeah.
Yeah. You use 0 and 1 because you have already defined it over here. This is why we need standardization.
So if this is more than, so it means that it'll be on the right, right? The tail.
Correct. You just follow the direction of where this arrow is pointing.
2.563.
Okay. So 2.563. So right here, like I say this is a bell-shaped curve, right? Okay.
Yeah.
At this point is 0. Make sense? Because the
Yeah.
mean is 0 ma. Okay. Then since we know it's right tail means the probability is on the right. Correct? Make
Yeah.
sense to you? So then after that, we have to look at the probability here. Is it a big probability or a small probability? Because this will determine whether this 1.8 minus mu over sigma is over here or over here, you know.
Mm-hmm.
So this is 0.1. Is it a small probability or big probability?
Small.
Small. Okay, how do you know whether it's small? If it's small, it's lesser than 0.5. If it's big, it's more than 0.5. Okay, since it's small, okay, so, and we know it's right tail, we should be shading a smaller area. Okay, we should be this. Understand?
Yeah.
Yeah. Which means our 1.8 minus mu over sigma will be over here.
I have a question.
Yes, ask.
If 0.1 is
Mhm.
a small probability, then shouldn't it be on your left?
Here, right? You're talking about this?
Isn't that your right? Like the one that you shaded?
Oh, sorry. Sorry. I said left, is it?
Yeah.
Sorry. It's right. Just follow this thing. This triangle. Sorry, this arrow is on the right. My bad.
But 0.1 is a small probability.
Yeah. It's a small probability. It means
So,
when the value of Z, okay, is greater than this value, is only equals than 0.1 probability. Means the shaded area is only 10% of the whole area, which is here. When it's greater than 1.8
where is
minus mu
here?
over sigma. Hmm?
Okay.
When the value of Z is greater than this value, which is over here, when it's greater, it should only have a shaded area that is 10% of the full area.
Okay.
You understand?
I guess.
Means you don't.
Mm.
Why do students always like to do this? Like they always say, I guess, maybe, but actually they don't. Yeah, okay, never mind, I explain again. When you see, you have to understand what this statement here, you can see my mouse, right?
No.
Oh, you can't see my mouse?
No. Your mouth is frozen.
Okay. Can you see my mouse?
Yes. but it's very laggy.
Okay. So when you see that this Z is greater than 1.8 minus mu over sigma, okay, this means that we want to find a probability where any value of Z, okay, it can be from the negative values, 0, positive values. I want this, when this value is greater than 1.8 minus mu over sigma, I do not know what is this value, okay? I do not know what is this value. This value can be 1.2, okay? Let's take this value as 1.2, for instance. When this value is 1.2, when Z is greater than 1.2, the probability is only 0.1. So on this curve, how the probability is denoted is through means of shaded area. Probability basically just means area. Okay, so when Z is greater, when the value is greater than this value, which is 1.2 over here, this whole area, you can see my mouse, right? This whole area over here.
Hello?
Can you see me? Can you hear me?
Oh no.
Can you hear me? Can you hear me? Can you hear me?
Hello?
Can you hear me? Can you hear me?
Yeah. Yeah.
Okay. So this whole area over here, right?